Hello everyone and welcome to this video on complementary metal oxide semiconductor. So you will be discussing the logic family of CMOS logic family. This is like a series of videos under the course of digital design, the fourth semester students, and coming to today's discussion on what would be the lecture outcome. You will be able to analyze the operation of CMOS gates and so once again we'll look at the logic family. So here already we have discussed the different logic families. Logic families have been classified in two categories, bipolar and unipolar logic families. So in under bipolar, saturated and the bipolar logic family, saturated we have seen completed. Non-saturated has been completed, all the logic families. And coming to the unipolar logic families, we have been completed the NMOS, and today's discussion would be on CMOS. Before we go ahead with this one. So in the last class, we have discussed about the MOS transistors, how it will be turned on and what would be the voltages. Okay. This one you can take it later on. So first of all, MOSFETs are of two types, NMOS and PMOS. There are two types of MOSFETs, NMOS and PMOS. When you go for NMOS, NMOS is turned on when the voltage is high. It is on when voltage is high. It is off when the voltage is low. Similarly, when you go for the PMOS, it would be a vice versa property. When you say PMOS would be on when the voltage is low. When the voltage is low, it is on. And the voltage, when it goes off, when the voltage is high. When it is high, it is, so it is opposite to your NMOS. So when you are connecting both these two, we'll get it in a complementary metal oxide semiconductor. So the reason we call complementary is that NMOS and PMOS work in complementary fashion. We can say when you go for NMOS, when it is on, PMOS is off, and when PMOS is on, NMOS is off. So this would be the property. That's the reason we say it as complementary metal oxide semiconductor. These are the list of advantages of CMOS circuits. First one is power consumption is less, large fan out, noise immunity and noise margin are good over here. And first one is power consumption. It lets very less power consumption and large fan out. Very good fan out we are having. Fan out is very good over here. And noise immunity and noise margins are we will be having a better noise margins and better for that. And power dissipation, low power dissipation is the very good factor and faster than NMOS. The disadvantage is that because NMOS we will be having only N types in MOSFETs and PMOS would be having the MOSFETs. But when you go for CMOS, you would be having NMOS as well as PMOS. So the cost of this one would be more. And propagation delay is higher than TTL and ECL. When you go for this one, it is higher than TTL. So when you go for the applications of the CMOS circuits, so when you go for the applications, it is used for these are the list of applications where we can see. So coming to the fan in, fan out, power dissipation, we'll skip off this one. We go for designing the circuit of PMOS, how this circuit will be working in out. This one over here, you can see when you apply an input as 0. The first case we will go for applying input as 0. So what happens over here when you apply the input as 0? I told you previously, a PMOS would be on and NMOS would be off. So here the VDD, which is been VDD is equal to 5 volts, it would be moved towards your output. As there is no path to the ground, so output would be what? 5 volts, which is equal to high, logic high. And when you apply 5 volts on logic high voltages, what happens is that PMOS is off and NMOS is on. When NMOS is on and PMOS is off, so there is no voltage appearing at the V over here. So the total voltage over here it would be equal to what? Zero. So this is one of the CMOS inverter. Coming to the one thing you need to remember is that when you go for pull up and pull down networks, pull up network should be made up of all the you will be having a pull up network, you will be having a VDD over here, and it pulls your this is called as high because once you are making this pull up network is been on, it pulls your I'm going to say it takes your output to be high, and pull down network will be making your output to be low. Usually, when you go for an when you go for an pull up network, you would be having PMOS, and pull down network you would be having NMOS. So one more thing you can remember over here. Whenever you are having an AND expression, mean to say A dot B is there, when you are having AND expression, usually we will go for taking an over here two expression where NMOS it would be connected in series. The same thing when you are going for an PMOS, it would be connected in parallel. So this is the pull up and pull down network. How this would be there. So let's take one of the. This is what and one of the expression and or we say it as and or inverter and or inverter AOI gate. This is one AOI gate. This is what or expression then and expression in inverter. This is what OIA gate. So when you go for and or gate and or and invert gate and or inverter AI gate and OAI gate. So when you go for this one, you can see over here when you go for AND expressions, NMOS are connected in what? Series. When you see this one, A and B are connected in series. And PMOS are connected in what? Parallel. The same A and B are connected in parallel. Then these two OR expression, they would be having a series. So C and D are series, this one. The same thing applies for OR, it is connected in series, parallel over here. So once you remember this one, pull up and pull down. So about this line, we say it as a pull up and pull down. Now we'll go for two input AND gate, NAND gate, sorry. Two input NAND gate expression would be given as what? The expression is like this way. What is that? A dot, suppose if I take it as A dot B whole prime. So what it is? And invert. Okay? And invert. So when you go for AND, NMOS should be connected in what? Series. PMOS should be connected in what? Parallel. So here it is with parallel. We will see the whether it follows that one, whether you are getting an output correctly or not. Let's take the first case when both the inputs are 0, 0. When both these are 0, zeros. So when both are 0, 0, this is off. Mean to say open switch. This is off, open switch. And these two are conducting on. So output would be equal to what? High. So you can see this one. Output is high. Let's take the case one of the input is made as high. Even though one of the input is made as high, this one is high over here. This is low. Exactly. So here also, this is open switch, this is a closed switch. There is no path. So output would be high again. Let's take the case when both the inputs are high. We'll move to the third case when the fourth case. And again, the same thing happens with the third case simultaneously. When you go for this one also, it will be the same. When you go for the fourth case, when both the inputs are high, when both the inputs are high, what happens is that these two are conducting. It is on a closed switch, and the VDD would be moving towards. Let us say there is no connection. These are off. This is off, this is off, with both is on. So there is no path for the VDD to go to the output, and it would be output would be equal to the ground voltage or low voltage. So this is a NAND gate. Similarly, you can have an NOR gate in the similar way. In NOR gate, we will be connecting both the inputs as expression for NOR gate is what? A plus B whole prime. It is what? OR invert. OR means what? The transistors, NMOS transistors should be connected in what? Parallel. So the vice versa, opposite to of that one would be NMOS, PMOS should be connected in what? Series. So this is about and similarly you'll be having an transmission gate connected one or the other. One side having a transmission gate like this way. We'll have a discussion about the transmission gate later on. So, so this, obviously, once we have discussed this one, by this lecture, you are able to analyze the operation of CMOS gates. Okay? And try to get this one, explain the working of CMOS NOR gate and NAND gates, and outline the working of transmission gate. Once we discuss the transmission gate in the class, you can get to about transmission gate and outline the characteristics of CMOS. Okay. More tutorials will be solved, and if you want to go for further reading, you can refer Morris Mano or Pigeon Tech. Okay, or you can go for any online sources of this one. Thank you for watching this video. Next video we will be discussing on complementary gate as well as the comparison of all the logic families.